This is a video that's designed to teach you how to solve radical equations. I'm going to go through these examples pretty quickly, and of course you are welcome to stop the video, rewind the video, fast forward the video, do whatever you need to do so that by the time you're done you can complete a problem set about radical equations. So let's suppose that we were to graph y is equal to the square root of x. And that graph looks something like this. It goes through 0, 0, and 1, 1, and 4, 2, and 9, 3, and we get this thing with this gradually decreasing slope, something like that. And let's suppose we graph another line, y equals 2. Oh, okay, we know what that looks like. It's a horizontal line, and that horizontal line would be right here when y is 2, and we can see that the two functions intersect at this point. 4, 2. And that tells us something. That tells us that if we were to set the y values equal here and write square root of x is equal to 2 and get this equation, the solution to this equation would have to be 4. Now you can see that. You can see if we plug in 4 here, square root of 4 is equal to 2. But here's how we actually use inverse operations to solve it. We take the square of both sides of the equation. And the reason that we do that is that the square root and the square, they undo each other. We end up with x on this side. On the other side, 2 squared gives us 4. So there's your first radical equation. Let's look at another one. For example number 2, suppose we have 2 multiplies the square root of x plus 20 minus 4, and all that is equal to 6. And I'm going to tell you the answer. The answer is x is equal to 5. And so let's take that answer and let's plug it in and show why it works. So what we're really starting with here is a check. If I plug x in right here, we should be able to show that this side of the equation is equal to the 6. And we're going to do that by starting inside the radical. So if we add the 5 and the 20 together, we get square root of 25. And next we would evaluate the square root of 25, which is equal to 5. And 2 times 5 is equal to 10 minus 4. And so 10 minus 4 gives us the 6. So we know it's the answer. Now let's come over here and look at how we would actually solve that equation. So write it again. And the first step, this will be the first step for all the equations you solve, is to isolate the radical. The radical is this piece of the equation. And since it's being multiplied by something and something's being subtracted, we treat it just like we do a linear equation, and we add 4 to both sides, giving us 2 radical is equal to 10. And then since we still want to get that radical by itself, we're going to divide both sides by 2 and get that the radical is equal to 5. All right, so we've done this. We've isolated the radical. The next thing that we're going to do is we're going to square both sides, just like we did in the first equation. So square here, square here, square, square root, undo each other. We get x plus 20. On the other side, 5 squared gives us 25, which brings us to the last step, which is to solve for x. We subtract 20 here, we subtract 20 here, we end up with x being equal to 5. Let's move to the next example. So this time, suppose we've got the square root of 3 times x plus 12, and we know that that's equal to 3 roots of 3. And I'm going to tell you the answer to this one as well. The answer is that x is once again equal to 5. And we're going to start with a check step. So let's look at y. On this side, I'm going to plug in the 5 for x. And then I'm going to simplify inside the parentheses, so I get 15 plus 12, and that gives us the square root of 27. Now notice that that doesn't look the same as this. Sometimes to check that your answers are the same, you will have to simplify the radical. So in this case, we would rewrite this square root of 27 as the square root of 9 times the square root of 3. And of course, we know the square root of 9 is 3. Okay, so now this and this match. Now let's actually solve the equation. Here we go. Square root 3x plus 12 is equal to 3 roots of 3. Step 1 is always to isolate the radical. Well, the radical is already by itself, so we can go ahead and square both sides of this thing, which is easy on the left. The square and the radical just undo each other. We get 3x plus 12. On the other side, this might take a little bit of work. If you want to square 3 roots of 3, that means that you square the 3, kind of like showering the power, and then you square the radical 3. Okay? So here we get 9, here we get radical 9. So that's 9 times 3, which is 27. Okay. Now we can solve this equation by subtracting 12 from both sides. We get that 3 times x is 15. And then we divide by 3 on both sides, and we get x is equal to 5. Exactly as we expected. Let's go to the next example. For example number 4, I want to look at a problem where we've got some fractions involved. So for instance, suppose we had something that looked like this. 1 minus 4 times radical 2r over 3 is equal to 0. Well, for this one, step 1 is to get that radical by itself. So we say the 1 is added on, the negative 4 is multiplied. Let's subtract that 1 from both sides. We get negative 4 times radical is equal to negative 1. We divide by negative 4 on both sides. We get that our radical is equal to 1/4. First step complete, radical by itself. Now we're going to square both sides. When we do that, on the left, we get this. On the right, we need to square 1 over 4. So that's 1 squared over 4 squared. So what we end up with here is 2/3 of r is equal to 1 over 16. And now since you've got a proportional equation, you can multiply by the reciprocal on both sides. And we get that r is equal to 3 over 32. Let's go to the last example. One of the tricky things about radical equations is that sometimes there's no answer. So let's look at an example of one that has no solution. All right, so you got a radical plus 1 equals 0. And you say to yourself, well, I'm going to start by getting that radical by itself. So let's subtract 1 from both sides. We get radical x plus 9 is equal to negative 1. And you have to stop right there. And the reason is that this says the square root of something is equal to a negative number. Okay? This right here must be positive when you have radical equals number. And if it's not, then there's no solution. So that concludes today's lesson. What I want you to do now is go on to the second segment, which is to complete these problems on a separate sheet of paper.